Hello friends, welcome back to the Trigonometry crash course. So we will be solving a few questions here. These questions will be solved using the formula and the theory we revised in the previous video. So let's look at the first question. First question gives us the value of theta. We don't know what theta is, but gives the value of tan theta here as 1 minus e square. E can be anything here. The question is to find the value of secant theta plus tan cube theta cosecant theta. So let's start. So tan theta is 1 minus e square. So automatically we know what is secant square theta. Secant square theta is 1 plus tan square theta. Tan square theta. Now the given expression secant theta plus tan cube theta cosecant theta can be written as secant theta. Now I'll write the tan cube theta here as tan square theta into tan theta, and tan square theta, so that is tan square theta. The remaining tan theta I will write as sin theta by cos theta. Now cosecant theta is nothing but 1 by sin theta. So what I have essentially done is I can cancel this sin theta here. So I'll get secant theta. Now 1 by cosecant theta is 1 by cos theta is nothing but secant theta. So what I get is tan square theta plus 1 into secant theta, taking the secant theta common. Now tan square theta plus 1, which we just wrote in the previous page, is nothing but secant square theta. As you can see here, tan square theta is equal to 1 plus secant square theta. Let's call it 1. So using 1 we can see that tan square theta plus 1 is nothing but secant theta. So this is nothing but secant square theta into secant theta, or secant cube theta. Now secant square theta is 1 plus tan square theta. So actually this can further be written as secant square theta power 3 by 2, right? So this is 1 plus tan square theta, again using that same formula, power 3 by 2. Now we know that tan square theta is 1 minus e square. So this is 2 minus e square power 3 by 2. So this is the final answer. Secant theta plus tan cube theta plus secant theta is equal to. So as you can see here, we had to use the identity secant square theta equal to 1 plus tan square theta. Just using that and manipulating the equation again and again, we get back in terms of the given trigonometry ratio tan theta, and we get the answer as 2 minus e square power 3 by 2. So let's go to the second question now. So this question actually is a very important one, because these kind of this is used not only in mathematics but in even other fields like even physics and chemistry sometimes, to find out the argument here, right? So the question is sin theta is equal to minus r and tan theta is equal to 1 by root 3. So this is the same argument theta, and we're supposed to find out the general value of theta. Mind you, the general value, it's not only one value, it's the general value, because theta is nothing but repetitive. So satisfying both of these conditions. Let's start. Now sin theta is equal to minus half, and let's find all the possible solutions of this in 0 to 360. Okay. So this gives us theta is the possible values theta can take are now sine of 30 degrees is half, and sine of 180 minus 30 is nothing but minus sine 30. So theta can be 5 pi by 6 I write it in terms of radians because that is actually the correct unit. We can write it in degrees also. That makes sense too. But writing in radians is always more preferable. Fine. So theta is. Oh, I'm really sorry. This is a small mistake here. Sine of pi plus theta is minus sine theta. So this should be 7 pi by 6. This will be 210 degrees. 180 plus theta will be minus sine theta. The other possible solution is 11 pi by 6. Sine of 2 pi minus theta is also sine of 2 pi minus theta. I'll write that. Sine of 2 pi minus theta is sine of minus theta because this is multiple of 2 pi. That is nothing but minus sine theta. So now, 11 pi by 6 is also one solution. Where is this now? Okay. Similarly, let's find the solution of tan theta equal to 1 by root 3. Now tan theta equal to 1 by root 3 one is directly 30 degrees, that is pi by 6. The other solution will come in the third quadrant where again tan theta is positive. Now we know that tan has a period of pi. So pi plus pi by 6 will also give a solution, that is 7 pi by 6. So we see that this and this, these two are common here. I mean, this is the common solution here. So theta must be 7 pi by 6. So theta is 7 pi by 6, but this is only one solution in 0 to 2 pi. 7 pi by 6, which is actually the same thing as 210 degrees. So this is just one solution. Now adding 2 pi or subtracting 2 pi or any integral multiple of 2 pi will always give the same thing. That's what an allied angle is. So the general solution will be theta is equal to 2n pi plus 7 pi by 6. I'm sorry. This is n not. So 2n pi plus 7 pi by 6. The only thing you have to note here is n is an integer. So it can take positive, negative, 0, anything. But only integral values, that is 1, 2, minus 1, minus 2, these scalar numbers. So this is the value of theta satisfying the answer. Okay. So let's go to the next question now. The next question is, if sin x plus sin y is equal to root 3 into cos y minus cos x, show that sin 3x plus sin 3y is equal to 0. Now this is where we'll be using the sum to product kind of formula. So let's start. Now we know that sin x plus sin y is 2 sin x plus y by 2 cos of x minus y by 2. Similarly, cos y minus cos x. This one, this is a slightly tricky one. So this is sin of x minus y by 2 and sin of x plus y by 2. If you remember, last time I remember I focused on checking the parameters here. The parameter switch here. It's not sin of y minus x by 2, it's sin of x minus y by 2. So if it is cos y minus cos x. So these are the conditions. Now we have a relation sin x plus sin y equal to root 3 cos x plus cos y minus cos x. So let's substitute these values now. So we have 2 sin x plus y by 2 cos of x minus y by 2 into root 3 times. Remember there is a root 3 in front of the expression there. So into root 3 times sin of y minus x by 2 sin of x plus y by 2. Now the 2 cancels, and let's bring everything to one side. So we see that there is an x plus y by 2 common here, into cos of x minus y by 2 minus root 3 sin of x minus y by 2. Now remember one thing here, you cannot simply cancel this sign of x plus y by 2, because sign can take a value of 0, sign can very well take a value of 0, so this kind of cancellation is forbidden. This is completely wrong. So remember that sign of x plus y by 2 here cannot be cancelled. So these are the possible roots of the equation, either sin of x plus y by 2 is 0, or the next term cos of x minus y by 2 minus root 3 sin of x minus y by 2 equal to 0. So let's take the first one. The first one is sin of x plus y by 2 equal to 0. What does that mean? Let's write the general solution. General solution means this is nothing but sin of n pi, right? Sin of sin of 0 is 0, sin of pi is 0, sin of 2 pi is 0, sin of minus pi is 0. So x plus pi by 2. Now since this is the general solution, x plus y by 2 must be equal to n pi. That's the benefit of writing it in the general form, general form. You will never be ignoring or missing out any of the solutions. So x plus y is written as, just let's write y in terms of x. Okay, so this is the first possibility, minus x. So this is our y is 2n pi minus x. Now we're supposed to show that sin of 3x plus sin 3y is equal to 0. So let's start with the LHS. So the LHS is sin 3x plus sin 3y. So it is sin 3x, but in y we have y is nothing but 2n pi minus x. This is sin 3x. Now what is the inside one? The inside is nothing but 6n pi minus x. Now 6n pi is nothing but it's again a multiple of 2n pi. So we can actually write that again as 2k pi. So this is this is a minus 3 here. So this thing is not, you can remove this part. So that actually gets removed. So this is nothing but sin of minus 3x. So this is sin of 3x. Sin 3x plus sin of minus 3x, which is nothing but minus sin 3x. Hence this is equal to 0 as ours. RHS. So proven. But will be let's take the second case now. The second case is, the second one actually has more work and calculation here. So this is cos of x minus y by 2 minus root 3 sin of x minus y by 2. So that part is 0. Cos of x minus y by 2. So that can be written as root 3 times sin of x minus y by 2. So this means tan of x minus y by 2 equal to 1 by root 3. Now 1 by root 3 is nothing but tan of, again, n pi by 6 plus pi by 6. Pi by 6 is the principal solution, n pi adding because tan has a period of pi. So we get that x minus y by 2 is n pi plus pi by 6, or x is y plus 2n pi plus pi by 3, right? I'll write this as x is y, 2n pi plus y plus pi by 3. Okay? Because I can remove this 2n pi easily if I ever encounter a trigonometric ratio. So now let's look at the LHS. Sin 3x plus sin 3y. So my x is 2n pi plus y plus pi by 3. So what is 3x? 3x is 3 into 2n pi, that is 6n pi plus 3y into 3 into pi by 3, so that is pi, right? Plus sin 3y. 6n pi is just an addition of 2n pi, so that part cancels. It's 3y plus pi. Now we all know that 3y, anything plus pi of sine becomes just minus of that angle. So this is minus sin 3y and this is plus sin 3y. Hence this is equal to RHS. Hence so the key concept used here was conversion of this sum to product formulae. We have sin x plus sin y, convert them into sin of x plus y by 2 cos. Using these formulae we find out the roots, and using the roots we give the proof here. So let's go to the next question now. Now these kind of questions are used again a lot in finding the maximum and minimum values of say certain equations. You may encounter them in various strata of science. So here actually it's a very simple one, but this gives you the general idea how it is done. Okay. So we have a sin theta plus b cos theta. Again a and b are real numbers. Now why I stress on real numbers will be evident from the next line. So now when there are two real numbers a and b, we can always write them in terms of there is something called polar coordinates. Now if you have done that, you will be familiar with this. Otherwise also it's not a very difficult thing to understand. So we can always write them in terms of two polar coordinates such as r and theta, or r and alpha in this case. So I write a equal to r cos alpha and b equal to r sin alpha. This is a very simple but very important powerful substitution. Okay, so a is, because now here r is always a positive number here, and alpha is also a real argument or real angle. Okay, now let's just square and add these equations. What do we get? A square plus b square is equal to r square cos square alpha plus r square sin square alpha. Now taking r square common, cos square alpha plus sin square alpha is 1, so you get r square. Okay, so this is the first thing. And second is, taking the ratios, we get tan alpha is equal to b by a. Okay. So these will be used in a lot of other things. Other problems, they will be using these formula substitution. For our question, this much is enough. A equal to r cos alpha, b equal to r sin alpha. Now let's take the expression. Let the expression be s. S is a sin theta plus b cos theta. Let's do our substitution. It's r cos alpha sin theta plus r sin alpha. It's cos theta. So this can be written as r into cos alpha sin theta plus sin alpha. Let's take r common here. Right. Now we are back to cos alpha sin theta plus sin alpha cos theta, that kind of expression. Okay, so this is nothing but, this can be again contracted into this. r into sine of alpha plus theta. The sine alpha plus theta when expanded is this. So our expression is nothing but, right? So our expression S is nothing but r into sine of alpha plus theta. Now we note that sine of anything, sine of any angle is actually, it always lies between 1 and minus 1. Fine. So just multiply the whole thing with r. We have r sine of alpha plus theta lies between this. But what is sine alpha plus theta? R sine alpha plus theta is nothing but our given expression a sine theta plus b cos theta. A sine theta plus b cos theta, that lies between r and minus 1. Hence the maximum value is, now it's r, but what is r? I just showed earlier, r square is root of a square plus b square, so r is root of a square plus b square. Minimum value would be minus root of a square plus b square. So this is how we are supposed to do this question. So it's pretty simple. We are just supposed to do the substitution. Once the substitution is done, it becomes fairly simple. So let's move to the next question now. Now trigonometry, as I said, is it was basically done for angles or the study of triangles. So now because there is a constraint on the sum of the angles, which is a plus b plus c is equal to 180 degrees or pi radians. So there are a lot of things which come from there. Now this question is also based on that itself. So the three angles a plus b plus c equal to pi may not be angles of a triangle here, but just because their sum is pi, we get a lot of interesting and important results. So the question goes on to ask us the minimum value of cot squared a plus cot squared b plus cot squared c. So let's see how this kind of question is to be done. Now this question actually is a pretty it's a very good question because it involves a lot of concepts. Not just this, we will also be using a lot of arithmetic here. So I hope you're all aware of this very famous and important inequality, which says arithmetic mean is greater than or equal to geometric mean. Fine. So this is the key concept to be used here, because the question asks us the minimum value. So somehow we'll be using some kind of inequality here. As it turns out, this is the inequality we're supposed to use. So the arithmetic mean. Now let's consider these numbers: tan A, tan B, and tan C. Now we know that for three angles having the sum equal to pi, this is the result: tan A plus tan B plus tan C equal to tan A, tan B, tan C. So this is the result. Already proven. You can prove it just taking A plus B equal to pi minus C. Take the tan on both sides, just expand and you will get this result. So this is not very difficult to derive. So we will use this result. Tan A plus tan B plus tan C is equal to tan A, tan B, tan C. But using the inequality A greater than GM, we get tan A plus tan B plus tan C by 3 is greater than or equal to this is arithmetic mean. The geometric mean is the multiplication tan A, tan B, tan C power 1 by 3. This is the geometric mean. Now from the previous identity we get Tan A plus tan B plus tan C is nothing but tan A, tan B, tan C. So tan A, tan B, tan C by 3 greater than or equal to tan A, tan B, tan C power 1 by 3. Let's just cube these three, both of these sides, and this is what we get. Okay. So let's cubing both the sides, and one of the sides actually gets cancelled. So we just have squared on the left side tan A, tan B, tan C squared is greater than or equal to, whereas 3 is cubed, so it is 27, or tan A, tan B, tan C is greater than or equal to 3 root 3, the square root of 27. Now let's just take the reciprocals on both sides. Now once you take the reciprocals, the inequality sign will change. So we have cot A, cot B, cot C is less than or equal to 1 by 3 root 3. This is very important to our answer. Now once that is done, let's go back to let's take these three numbers. Consider cot squared A, cot squared B, and cot squared C. Now let's again apply the AMGM inequality, and we have cot squared A plus cot squared B plus cot squared C by 3 is greater than or equal to cot squared A, cot squared B, cot squared C power 1 by 3. So this is equal to, so this greater than equal to sign here, but here it will be equal to, because I am equating the right hand side to something which is cot A, cot B, cot C power 2 by 3. So cot A, cot B, cot C that was less than or equal to 1 by 3 root 3, whereas cot squared A plus cot squared B plus cot squared C by 3 is greater than or equal to cot A, cot B, cot C power 2 by 3. So the minimum value will be nothing but the equality here, which is 1 by 3 root 3. So this is equal to 1 by 3 root 3 power 2 by 3. Expanding that we get this can be written as root 3 power 3, so it's 1 by 3, that's it. And on the left side we had, so left side, so writing the whole equation again, we have cot squared A plus cot squared B plus cot squared C by 3 is greater than or equal to 1 by 3, or cot squared A plus cot squared B cot squared C greater than or equal to 1. Yes, this is the minimum value. So this is how we are supposed to do this question. This question requires us to use the inequality AM greater than or equal to GM. Once that is done, everything else is pretty simple. Apart from that, the identity, that's why remembering this identity is actually pretty important, because tan A plus this is very simple to remember. At the same time, it's pretty important, pretty powerful also to use this solve these kind of questions. So this is for this question. Let's go to the next question. So this question says, simplify the product cos A into cos 2A into cos 2 squared A, and this the whole chain goes on till cos 2 power n A. Now remember it's 1 then 2, I mean the product of A, 1 2 then 2 squared, it's not 3 here, and then it must be 2 cube 2 power 4 till 2 power n. So let's see how to solve this kind of question. Now we'll use the multiple angle formula here. Sine of 2a is 2 sine a cos a, or that means cos a can be written as 1 by 2 sine a into sine 2a. Right. So the LHS will be cos a cos 2a cos of 2 squared a. These dots indicate the same trend being followed. So the first one cos a, that I'll write as 1 by 2 sine a into sine 2a. 1 by 2 sine a, 2 sine 2a. Now the remaining thing again. So cos 2a, because only the first thing has been removed, first cos 2 power n a. So sine 2a into cos 2a. Now this is nothing but sine 4a by 2. Okay, from using again this formula. So this can be now reduced as sine 4a, but that is sine 4a by 2. So we already had a 2 here, becomes 2 squared sine a, and this becomes sine 4a. Now this cos 2 squared is nothing but 4a. So this becomes sine 8a, but again by 2, so I'm sorry, it should be a cube here. Okay. Now the next term is actually cos 2 cube a. It is just the same thing. So now following the trend, we see that, so if it's 8 here, there has to be 2 cube here. So let's take the last term here, cos 2n. So following this whole trend, it will be nothing but 2 power n sine a. Sine a remains just like that. Sine 2 power n a cos 2 power n a. You can see here, this is 8 here. A, the same thing, 2 cube is 8. So the same 2 power 2 cube is there. So this is to see that yes, you are going on the correct answer or not. So we have sine 2 power n here, cos 2 power n a, and there it must be 2 power n. So this is nothing but, now this can again be, final time you can use this, 2n plus 1 a by 2 power n plus 1 sine a. Hence, the whole thing has been simplified to cos a, cos 2a, all this till 2 power n a is nothing but sine of 2 power n plus 1 a by 2 power n plus 1 sine a. So this is how you can simplify this using the multiple angle formula. So as we saw in all these questions, we are just using the basic theorems, a few identities again and again to solve the questions. Obviously, a few questions will require specific approach, and as we saw in the fifth question, remembering a few identities actually saves us a lot of time and effort, because in the question can get very lengthy if you don't remember that, and you have to put extra effort to find also say to derive the identities. So it's better to remember some of the most important identities, and everything else then becomes pretty simple. You have to just use them again and see how to go ahead with the questions. Thank you for watching this video. In the next video, we'll solve a few more questions of varying difficulty, slightly higher difficulty actually. So thank you.